Hello, hello. Please put your headphones on. Perfect. Thank you everyone for joining today. My name is Talha. I lead agents across EMEA. I help customers adopt agents. Together with me today, I have Alina and Marcus from Electrolux joining and talking about how they adopt these agents at their organization. In order to understand agents, let's understand at first nature. Growing up, you might have been fascinated about the stories related to ants, how such tiny creatures are able to collaborate together, to lift up weights much heavier than their own sizes, never collide with each other, and always get home in a nice way. They get their jobs done, they get it done quite effectively, and they distribute tasks among themselves very effectively as well. Growing up, what you might have missed out, but this was the nature's way of telling us how to collaborate. The question is, in this modern world, how can agents collaborate? At each and every organization that you might be part of, maybe you belong to FSI, from any industry, manufacturing customer, or whosoever you are, I guarantee you there must be definitely some heavy lifting at your organization that you are doing. It could be expensive infrastructure that you have to migrate. It could be some code that you're writing. It could be some laborious tasks that you are not really keen about, and they are a burden to your organization. Question being, can agents, AI agents, help you remove this heavy lifting from your organization? That's the topic we need to discuss today. We will be talking about what are these AI agents, what agentic AI really means. How can you get started with building such agents? What are the first patterns that you will be adopting? What are singleton agents? How agents, when built together, can collaborate? What Amazon Bedrock agents can help you? What are our services there to help you out? And finally, we will listen from Electrolux, our dear colleagues over there. How are they adopting all of it? I see, naturally, there is a divide over here. Let's build a company together. Let's build a startup that is responsible for creating flying cars. Okay? So maybe engineering over here, maybe management over there, finance over here, and I can take the responsibility for marketing. As a marketeer, maybe I need to do certain research, maybe I need to create content, maybe I need to think of strategy of how should we position our products. The question being, can agentic AI help me do my marketing jobs effectively? One of the questions that we will be answering today. Before we answer this particular question, we need to understand what are the AI agents that we are talking about. We have worked with customers like yourself over the years in order to build a definition for that. To us, AI agents are entities that belong to an ecosystem. These are entities which are intelligent, are autonomous systems, and are powered by large language models out there. These large language models act as a brain for these agents. This brain helps them plan, reason, and act on top of the tasks that you provide them with. These AI agents are also empowered by the enterprise data. You part of certain organizations, these agents leverage your data, your APIs, and then convert them into tools so that they can use it to fulfill the tasks that you provide them. When we work with different customers, you are the ones telling us your challenges. You ask us that you need our help. Help in what? You have diverse use cases, you belong to all sorts of different industries, you have different maturity levels, complexity levels, and different things that you wish to achieve in your businesses. You want our help to make you move faster. I guarantee you that many of you are not IT businesses. That's not your core business. You maybe belong to manufacturing. You have assembly lines to monitor. Maybe you are part of retail, Or you're part of banking, where you have to serve different million customers out there. But managing IT infrastructure is not your job. You wish to move faster. Also, you are telling us that you need to have some sort of robust and scalable mechanisms to put solutions out there to serve your customers. We from AWS have listened to you and then come up with solutions that can help you. And that is exactly why Amazon Bedrock exists. And now with Amazon Bedrock, you also have possibility to create Bedrock agents. These agents, with the beauty of Amazon Bedrock, can leverage the large language models under the hood. You have the ability to connect your own tools, your enterprise data, as we previously talked about. And you can create action groups for these agents to take actions on your behalf. Last but not the least is that you also need some sort of governance, some sort of visibility on what is going on. Amazon Bedrock agents also come out of the box with certain tracing, debugging, and observability mechanisms. It is also possible today for you to build multiple agents and make them collaborate with each other via Amazon Bedrock as well. So, how can you get started? We help our customers to start small and focused. Let's imagine a scenario where you are building, by the way, summer is coming up, amazing time in Sweden. Maybe all of you want to go off on vacations. Maybe at your organization you wish to build an agent that can help employees to at first find out how much vacation they have left and later request time off as well. So you build an agent for that. How do you do it? You connect certain tools, certain APIs that might already exist in your system, or create net new which can connect with the databases which hold such information. So you connect to a database which has like time off details. So you can read from it for a certain employee and also write requests of time off into this database. You create this agent effectively, you roll it out, all of the employees love it, they're all gone in summer. When they come back, they're like, okay, that system was amazing, maybe we also need to make it better. So you launch a V2. This system is now responsible for maybe talking to them and providing more information about your HR policies. Yes, they were able to request vacation. Maybe now they need to know when can they request vacation. What are the policies related to that? So you extend this agentic implementation with more data within your organization, acting as V2. Now, that was quite successful, so you move on. Maybe you integrate systems for leave of absence. And on. Maybe you integrate this system to be more mature than a simple time off agent. You make it an HR agent responsible for promotions, for travels, and whatnot. But if you take a single agent so far, the question arises, how far is so far? This leads to certain challenges. Agents become quite complex. The coding that is required in order to build such agents is also quite complex. You have to maintain multiple different tools. You have to maintain the data. You have to write the prompts and make sure that these prompts are working fine, choosing the right tools at the right time. And you have to maintain all of it in production. Agents also get confused. Believe me, it's not just humans who get confused, agents do as well. How do they get confused? What if you have created two different tools that roughly do the same thing? What if they cannot disambiguate between vacation and leave of absence? Maybe the definitions of these are different in your organization. Agents also get slower. Why do they get slower? Because under the hood there is an LLM, which is powered by a prompt. All the definitions of tools and data get part of the prompt, which the agent now has to process to come up with effective plans. And they also get expensive because prompts relate to tokens and tokens relate to dollars that you are going to be paying. So what's the solution? One solution could be that you go on and create some specialized agents. So instead of you adding capabilities to just one big agent, you could now create specialized one, maybe one for time off, maybe one for leave of absence, maybe one for promotions and so on. So the questions related to each one of those can go to the specialized ones, right? The question related to leave of absence can only go to that agent. The question related to promotion can go to that particular agent, and then they use their own tools. So what have you achieved? In your organization, you could create different teams, different projects, and then they build their own agents. Voila. But you start from 3. Soon you have to maybe build 5, or 10, or 50, or 100. Or maybe you are a multi-billion organization operating globally, you have to go to thousands of agents out there. Can you expect your people to only, or to go on and talk to 1,000 different interfaces out there? Maybe no. So what do? This leads to certain challenges. You most definitely get some splintered user experience, right? They have to talk to different systems in order to fulfill their task. And once you start doing it yourself, building, maintaining, and operating multiple different agents in production becomes quite hard. And finally, also, complex automation for complex tasks become quite crucial, and it still is unsolved. What if somebody wants to get promoted but has taken parental leave, and they want to know the answer whether they can be promoted this year or not? Maybe multiple different agents are required to answer this particular question. How do you do it? For this particular aspect, we have multi-agent collaboration support within Amazon Bedrock agents. This helps you unify the experience that you have built for multiple different agents and then connect them together. You can plan across the agents and execute actions across the agents as well. And observability as it comes out of the box with Bedrock agents still applies to multi-agent collaboration as well. There are two patterns that we allow our customers to build with Bedrock agents when it comes to multi-agent collaboration. One, router, the other, supervisor mechanism. The router mechanism allows you to unify the experience that your customers can get. Instead of them going and talking to individual specialized agents out there, they can just talk to one unified one. How does that happen? So let's take the same example of 3 different applications that you previously built. One for vacations, one for leave of absence, maybe one for promotions. You could replace all these 3 applications with one main agent. This agent can act as a router for the specialized agents that are already there. So when a user query comes in, this main agent decides which specialized agent can solve this particular query. When a different query comes in, it basically decides which other agent can take this on, and so on. This then acts as a one-stop shop so that as many agents or as many specialized agents that you have built can serve plethora of customers that you have internally or even externally out there and manage between them. So how does routing work under the hood with Amazon Bedrock? You begin by creating the specialized agents that you already were creating previously, right? You give them certain descriptions and tasks. What is it that these agents are capable of? When is it that they should be using? You attach the specialized tools, the data that they need, and then they work on top of that. Once you have that enabled, you then go on and create a particular router. Since this router is only responsible for figuring out which agent can do the job best, they can go on and then use a very small LLM under the hood to fulfill the job for you. This LLM then takes on all of the list of agents available, does the intent classification based on the request of the user that is coming in, and then route the request to that one. So let's have a look at an example conversation. So maybe somebody is asking how much vacation is left, right? For this particular question, the agent decides that I need to use the time of, the main agent decides that I need to use the time of specialist in order to fulfill this query. It routes the request to that one. And if a similar kind of a query comes again, that let's say, can I use it next week? The same conversation continues with that specialized agent. But then the question comes, if something else is being asked. Maybe somebody is asking for leave of absence or promotion, or both. Then that leads to no longer routing, right? Leave of absence while you want to get promoted maybe requires multiple different agents. So complex workflows come into place. That leads to our second pattern, which is the supervisor agent, where you can automate complex workflows with the help of Amazon Bedrock agents. Let's have a look at one of such examples. So you again work with certain sub-agents. Remember that I was part of marketing. We were all trying to build flying cars over here. So for such marketing jobs, maybe I need a marketing specialist, marketing strategist. Maybe I need a content creator, maybe a copywriter, maybe a report generator, and so on. So these are all the different agents that I might need in order to do my job or fulfill my tasks. So I create all of them and then connect them together with a supervisor. So this supervisor is responsible for orchestrating between the sub-agents and also come up with a multi-step workflow, or basically a plan that can be executed with the help of these sub-agents. So when a user query comes in, this supervisor is responsible for creating a plan and a comprehensive plan based on whatever access it has available, and then execute that plan based on the strategy defined, and then give back the unified result to the user. Practically speaking, when a user query comes in, it basically decides, builds a plan, and then hands off that particular plan to execute it by the sub-agents. For example, the step one is to perform certain research. It hands off that sub-task to a market analyst. Market analyst then divides this subtask into further tasks for itself to complete it for the user. Once that is done, it moves on to the second step in the plan. And then that particular agent, which could be maybe market strategist, in order to create its own class of subtasks to fulfill it. And this goes on with step 3, 4, 5, and so on until the entire task has been fulfilled and the plan has been executed on your behalf without you managing an infrastructure. At any company, our flying cars company, let's imagine we have to scale this in production for us to have effective marketing strategy. So how do we do it? We come up with a startup advisor. This advisor can connect with different kind of agents. There could be a lead market analyst, a chief strategist, a content writer, creative director, maybe a report writer as well, right? So I, as a marketing manager, I come up with a list of tasks for this, right? These agents also have access to our working memory. This could be, for example, Amazon DynamoDB, where they can write their tentative results or drafts, and then also request drafts from others who have worked previously so that they can iterate on top of this. So when my task comes in as a description, a project that I'm handing over to these agents, a supervisor, which is the startup advisor, breaks it down into multiple different steps, right? For example, research goes to lead market analyst. It writes its work in the working memory. That goes to the strategist. It writes its own work over there. Then that goes to the further agents such as content writer, which comes up with the draft content, right? It could also be the case that the startup advisor over here tries to take multiple turns between different agents in order to refine a particular artifact that has been generated by a sub-agent. And collaboration between different agents and loops in order to make it right based on the task that is at hand. Finally, once enough confidence has been gained, this goes on into writing report for that particular task and coming back with an artifact looking something like this. So you could see a simple markdown file, which is maybe for flying cars, marketing strategy, table of contents, some executive summary, an actual artifact that you can utilize in your business for the marketing related tasks. So using this, maybe flying cars can be quite successful in reality. Under the hood, what is really happening? What you're doing is you're providing a particular prompt, or Bedrock Agents is providing a prompt on your behalf. You're giving it some project or task description. You could be coming up with different tasks, maybe task 1 that is related to research, task 2 that is related to content writing, and so on and so forth. You could describe how these tasks have been formed and how they should be fulfilled on your behalf. You could see over here that as part of step 1, what you see is that it has given it to the startup advisor, which has further given as step 1.1 to a sub-agent, which further divides it into further subtasks and fulfill those. All of this you could see in form of a trace coming out of Bedrock Agents so that you have much more observability on top of it so that you could improve your own iterations and make effective agents in production. You could scroll all the way down where all of the steps and sub-steps have been fulfilled by the sub-agents to come up with a plan that then, with artifacts, then Startup Advisor can combine together in order to provide you with a final report. Now the question being, how can you build it? You start by your specific specialized agents. So for example, lead market analyst. You define what it can do, what information does it have access to, and what are the tools that it can utilize. You describe the tool definitions, and so on. You do it for all of the different agents available to you, and then finally go on and define your supervisor. In Amazon Bedrock, as I said previously, you could either choose a router mechanism or you could choose a supervisor mechanism. For this one, you choose supervisor. And then you give it a list of all the collaborators that you have at hand, and then it utilizes those collaborators in order to fulfill the task for you. Once you have defined these, you can go on and define the tasks at hand and further define the mechanisms to connect them all together. You could even give descriptions that, okay, you only need it to be executed sequentially or parallelly, or maybe apply certain guardrails and policies from your business as well. Such kind of mechanisms, if used, for example, Amazon Bedrock agents and the patterns that it allows you, you could build much more complicated and unlock complex workflows at your organizations. But that's not all. You could also build agents with the help of other features available within AWS. So for example, Amazon Bedrock inline agents allow you to build agents in real time and in a dynamic manner so that you have access as you develop or in a real-time manner based on the scenario, you could build effective agents that way. Recently, we have also launched Strands agent, one of the open source SDK built by AWS based on experience from different customers that you can utilize in production. Or we have partnerships with open source frameworks such as LangGraph or Crew AI, which you can build with using Amazon Bedrock Foundation models and put agents in production. Now the question is towards you, engineering or management or maybe finance. I did my part from marketing side. How is it that you are going to be using agents in production? One of the customers that we have, Electrolux, has already done it. I would like to invite Elena and Marcus to talk about how did they do it.
Hello, everyone. So we're from Electrolux Group, indeed. Most of you here in Sweden probably had heard about us before. In case you haven't, here you have some stats. So basically, it's a bit over a 100-year-old Swedish company, headquartered here in Stockholm. We do home appliances. We sell some 60 million every year. And ever increasing amount of these appliances are connected, smart appliances. So someone needs to make sure that it can talk via the cloud and you can control it via your phone. And this is basically the part of Electrolux that we work in. And we are me, Marcus Mäkelä. I'm a site reliability engineer at Electrolux. I'm here with...
Hi, my name is Arina Ostapovich. I'm site reliability engineer as well. And we work in platform team in the organization called Digital Experience.
Yeah, and as a platform team, what we do, we don't develop these smart features that are directly consumer-facing. Rather, we build for our developers. So we're more like a DevOps, SRE kind of team, and we do this by developing our internal developer platform. And this offers our organization with kind of self-service approach to provision cloud infrastructure and access management and other third-party tools. And by nature of this, we end up becoming kind of like the interface to our organization, to the cloud, and a lot of other tools. So anytime someone wants to do something a bit obscure, or if there's a problem, they will need to reach out via us. And they do it via Slack in general. We have a channel called SRE. This is the most popular one in the organization. On a normal day, it looks a bit like this. We try to answer and help out as fast as we can. But some days it looks a bit more like this. And as we're kind of a small team, we might end up being a bit of a bottleneck if we cannot help everybody in time. So the obvious solution to this is to increase our capacity. But instead of hiring a new joiner and having to deal with HR and all of this, we decided to see if we can build it. And this is what we're going to talk about today.
And that's how the idea of InfoAssistant, our digital team member, came to our mind. So what are our expectations from InfoAssistant? First thing that we want to delegate to it is the most frequent task that we do is answering on questions. But answers should be provided not on generalized knowledges, rather they should be tailored specifically to our organizational setup and terminology that we use. Also would be nice if InfoAssistant can do some actual help, because, actions speak louder than words, and we would love InfoAssistant to execute some operations and do some more tasks than rather than just chat. Also, we don't really want to go and double-check all answers that InfoAssistant provides. We want to fully trust it and rely on it. And of course, I bet there is no developer in the world, or at least in this room, who wants to talk with arrogant and rude SRE. But if you do, well, we can figure something out. And keeping all these points in mind, we did it. We built InfoAssistant, and now it's the first member of our team who replies on all messages that has been posted in our support channel, like the one that Marcus mentioned before. Yep. Or if you are a really shy developer and you don't want to ask something publicly, you can always go and have a private conversation with it. But let's take a step back and see how the development of InfoAssistant went. So we decided to start slow, and for POC, we selected only first the requirements. It's Q&A on custom knowledge base, and we built it and did it with the help of knowledge base agent. A knowledge base agent allows you to implement pattern, which is called retrieval augmented generation. And this is overall high-level architecture of that system that we had back then. Please don't be surprised by the bird on IKEA service, because it's InfoAssistant logo and our team's spiritual animal. But nice thing about this system is that we don't really handling and managing all the parts of it. We are responsible only for these parts, like service that works as consumer interface for our developers, and thinking about which data to use for knowledge base, how to clean it and pre-process it. Because all the hard work, like problems where to host embedding and large language models, where to store vectors for our knowledge base, is handled by AWS. And let's see some small example. Here I asked InfoAssistant rather simple question, like how to provision a new instance of DynamoDB. And we can see from its answer that answer is tailored to our documentation, because it's mentioning IDP, the one that we have, and also there are references or to the documentation or to the previous chats if this question has been already asked before. And I think it's a really nice feature, because it gives our developers and our users that use ask InfoAssistant for help an extra point of evaluation, where you can double check that this answer was not generated only and hallucinated by LLM itself. It actually has some ground truth beneath it. Well, some time passed, and we decided that InfoAssistant also passed its probation period, and it's time to give and to teach him some new tricks. And those new tricks can be achieved by using multi-agent collaboration. Multi-agent collaboration allows you to implement another pattern, which is called chain of thoughts, where instead of telling LLM what to do and how to do something, you just fire a request, and then LLM thinks itself what it should do, which tool it should use in order to successfully complete your request. And here we have the main agent, supervisor. It does the main thinking and reasoning. And it also has a list of all accessible tools in the system. And by tools, I mean another agents. And those agents can be either standalone agents, like log search or knowledge base, for example, or those agents can act as another supervisor. So basically, this changing in the roles of agents allows you to build a really flexible generative AI system, where you are picking up how you want your system behaves. Some time passed, and our InfoAssistant has now even more tools. So this is our current state of agentic collaboration. And here we have 3 types of agents. First, and the most simple one, is knowledge-based agent. Basically, it's a scaled version of RAG application that we showed before. And for our documentation with a couple of iterations, we come to the conclusion that it works best if we have 3 different agents per data source. And picking up the right agent is delegated to knowledge base supervisor. Second type of agents, and actually my favorite one, is API agent, because those agents allows you to make an integration with external resources incredibly fast. Because you need to have only 2 things. First, it's uploaded OpenAPI specification, and secondly, Lambda that will make calls to those APIs. But picking up the right API from the specification, it's done by agent. And for example, if your request does not contain all necessary information to make the call to the API. For example, you ask to list members of some group. Agent can come back to you with an additional question, like, all right, you asked me to list members of a group, but can you please specify and provide me a name of the group? And the third type of agents, so-called classic agents or agents with action groups. Those agents just execute Lambda code that has been fully written by you. But here you can also do some nice and enable some nice features. For example, user confirmation. If your Lambda code do potentially run some vulnerable or sensitive code, or you don't really want to fully rely on an LLM, which you should not, you can always ask for additional user confirmation. So this confirmation will go back to you with a full output of what agent is going to execute and perform, and will ask you. And then your developer or user can yes, I approve. No, I reject. Let's move on. And picking up and then managing all those agents are handled by the main supervisor. So let's see the example of chain of thoughts. Here I asked InfraAssistant to pretend that Marcus is our new joiner, and he does not have access to any tools that we have. And from the logs, we can see that we have initial request, and LLM took some time and decided that, right, it sounds like a job for onboarding supervisor. Then LLM prepared instructions for those supervisor, and those supervisor, if you remember from the couple slides before, has its own agents. And this onboarding supervisor delegated task to Atlassian agent. Then we are thinking again, which parameters from the original request we should go and send back to Atlassian agent. And we can also see which API from Atlassian agent, because its API basic agent has been picked. And finally, successfully, Marcus is onboarded to our team. Welcome on board. And I have a first task for you, actually. Can you please tell us how we can deploy all these countless agents?
Yes, I can. Thank you. Yeah, so of course you can create this whole agentic tree or structure by going into Bedrock console and clicking around there. But as a DevOps team, that's not really how we want to do things. So of course we have everything defined in code. So when we want to make a change to some prompt or some links or add some tool to an agent, we basically push it and it will run a deployment pipeline which will deploy each of these agents and create this agentic tree in Bedrock. And then Bedrock basically gives us an endpoint which we can send questions to, and it will propagate through this agentic tree, however the LLMs decide it should. But as InfraAssistant started becoming more and more complex, this deployment started becoming a bit of a pain point for us, because it takes a while, and there's a lot of minor iteration needed for a system like this. So then we decided to try out inline agents. This is kind of a different approach to this. With inline agents, basically, we don't have to worry about the state in the cloud at all. So instead of deploying the agentic tree, we can just generate it in our service, and then we actually send the whole tree along as a JSON along with the question to Bedrock, and Bedrock will, with minimal delay, compile it and run the question via the tree. So it looks a bit more like this. So this allows us to iterate much faster, tune prompts and stuff like this, and we will always know that we don't have to worry about the state in the cloud, which, however the question will run is defined by whatever we send to Bedrock at the same time as the request. This also gives us a bit more control. So since we can generate the agentic tree dynamically during runtime, we can, with some tricks, basically have arbitrarily nested agents if we want. It also offers us an extra avenue for extensibility in a more convenient way. using MCP. If you're into agents, you probably heard a lot about the Model Context Protocol recently. It's an open standard developed by Anthropic, which basically standardizes how a large language model retrieve context and use tools. So what it means for us in practice is that if we support the MCP protocol in Infra Assistant, then we can very easily add capabilities by just running some MCP server, and then since it's supported, it will always be the same interface and it will just work out of the box. And there's a growing library of official and open source MCP servers that we can use for this, like GitHub has one, for instance. So then we can just run the GitHub MCP server and kind of ingest it in Infra Assistant service, and then we can talk with, interact with the GitHub API without having to write all of these tools ourselves. And with the inline agents API, we can fairly easily turn this MCP server into an action group, and that we can just plug into wherever we want to in our agentic tree. And also as a platform team, this kind of offers opportunity for other teams in our organization. If they would want to expose some endpoints or tools or data to us, they can just package them into an MCP server, and then we know it will be very easy to connect to our system. So using this slightly more flexible inline agent framework, here's one of the latest agents that we've been working on. So troubleshooting cloud issues is one of kind of a core part of our day-to-day work. This is a very difficult task. You need to both know where to look and what to look for. And we have a fairly complex cloud environment. But we employed this kind of sub-agent for this task. It has the supervisor, which orchestrates the whole troubleshooting operation. It also has access to our log management system, so it can query real-time data. It can search our code to try and find issues there. It can also have access to the knowledge base. So if there has been some similar issue before, it will know about it. And maybe most interestingly, it also has this AWS CLI agent. And this agent can run arbitrary AWS CLI commands in our AWS accounts. But it runs in an isolated environment with a restricted read-only role. You of course need to be very careful when doing something like this, or carefree at least. So due to the granularity of IAM, we know that since it only has credentials for this restricted role, even though if it want to deprovision prod clusters, it will not be able to. But does it actually work? I tried it out. So we have Transit Gateway to allow communication between AWS accounts. And I asked Infra Assistant in a normal state. I told it that I am having some issues. I lied. There were no issues. So it went in and checked, made sure that everything is configured properly, and it concluded that it actually looks correct. The issues are probably due to something else. But then I cut the connection. I took down the dev environment, and I asked it the same question again. And then it's actually was able to figure out the exact issue. So the security groups don't have rules allowing traffic from the other environment side range. This was exactly the issue that I introduced. This is pretty cool. It's also not cherry-picked, believe it or not. This was the first thing I tried. But in general, it's very difficult to quantify the performance of a system like this. We allow our developers to rate the interactions with this annoying pop-up, where they can rate 1 to 5 and add some feedback. General feedback is that it's kind of a convenient way to understand, get access to our institutional knowledge, but it's also somewhat slow, so you probably don't want to ask it about everything. We also want to see how it's performing in the SRE channel, so we're rating the accuracy of the answers. Here's a sample of that. And here one is hallucinated and some wrong information. This is obviously not good, but it happens. And number 5 is a senior member of our team. So the question was completely resolved by Infra Assistant. We didn't need to do anything about it. And in the middle, it's maybe the 4s are correct information, but it didn't have the tool available to help out properly. And these number 5s, these are really nice. We're trying to get more of them, of course. It's not only our time that's being saved, it's also the developers, because we cannot immediately always jump in and help out the second there's a question. But Infra Assistant is always ready. And also it scales much nicer. So if we would get like 50 times more questions one day for whatever reason, Infra Assistant will not be bothered by that, and it will be able to help out as good as it can anyway.
Well, even though Infra Assistant is not 100% accurate at all answering and all tools and actions that it do, we still see the benefits of having it as our team member. First of all, it really helps us saves our time when we need to complete some repetitive tasks like access management or answering on the same question over and over again. Even though Infra Assistant might, for some questions, it's like does not have knowledge enough, or maybe it's that time he had some break and did not reply correctly, and we need to jump into some request, it really helps us to see the answer that Infra Assistant wrote, because as it has access to all three main sources of information within our organization, for us it's much easier to understand the context of the problem, because we cannot be aware about everything that is happening across our organization, because we are quite big organization, to be honest. So it really helps us to understand the context of the problem. And if we will compare time that we would spend by doing all these manual tasks, trying to understand what is the problem, why does anyone need to access to Jira again, versus time and money that Infra Assistant costs us monthly, I would say that it's quite cost efficient. But we will not pretend that Infra Assistant is going to replace us. Me, Marcus, you soon. No, it's not going to happen. There's a room full of improvements. And the first thing that we want to do is to reduce that delay time. Because depending on complexity of the task, it might take up to several minutes for Infra Assistant to fulfill or execute some code. I mean, it's really boring to wait. Second thing that we would love to do is add advanced evaluation. Because instead of measuring the performance of Infra Assistant as end-to-end, would be really nice to see the performance of each agent separately. With that, we could either go and fix one small part of the system, or maybe we will see that some agent is not used at all, and we can delete it forever and forget about it. And also, would be nice if Infra Assistant can actually fix itself. Because all right, he might get a feedback that some answer was wrong. It could go and fix the prompt, or check their vector database on knowledge source or something. Because if we think and believe that it can help us with troubleshooting of our infrastructure, can't it also help us with troubleshooting itself? But these are the questions for the future. Now we not only build internal stuff, we also like to share with some projects that we do. And if you're interested, please check out our open source page. We have, I would say, multiple and several of really cool tools there. With that, thanks a lot for coming to our session, and going back to Talha.
Thank you. They say, if you want to go fast, go alone. If you want to go far, go together. Building single agents is already history. Something that you can quickly do is, yes, single agents. But if you really want value in your organizations, building together, building collaborative agents is the way forward. Just like how Alina and Marcus explained at Electrolux. Please scan this QR code in front of you on the screen in order to learn about the resources that we shared today with you. Oh, so, yeah, learn about these resources. Raise your hand if you are thinking about putting agents to test. Awesome. Keep your hands up if you already have agents in production. Amazing. It shows the value, or it shows the possibilities that we can do together. Don't forget about the ants. These are one of the most collaborative creatures on planet Earth. Learn from them. Scan this QR code and tell us how. My name is Talha, and together with me I had Alina. Thank you so much for joining us today.